He's 8 years old and in 3rd grade and likes building. This is my teammate, my other teammate, Yesh. He is 8 years old and is in 3rd grade and likes building. And this is the whole team Lego Smart. Now my teammate Sidan is gonna say about our research and how our robot evolved.
So, while evolving, first we were thinking about making the robot like fight mosquitoes and bugs, and then compared to fire, fire was a bigger thing, so we wanted like a bigger thing and a bigger project, and so we all voted, and then we picked fire. So now we're doing fire, and that's how it used to look, and we were thinking of ideas to make it like spray retardant or something, but now we made it so it follows you, but it also keeps a distance. So the ultrasonic sensor, it keeps the distance. And our research, we used the internet, and a guy came to our, we met him, and then he helped us with the programming, and we also used some books and the library. Now I'll give the speaking chance to my teammate Arjun.
Hello gentlemen, and I'm going to talk about our program. In our program, I'm going to explain to you what a switch block is, a sensor block is, what a sensor block is, what a loop block is, and a motor block. A sensor block makes a block is a unit of programming in NXT programming. A sensor block makes the sensor do what you want it to do. Let's say I programmed the ultrasonic sensor to see like 8 inches away and stop. And then you would have to use a switch block. Now a switch block is like 3 blocks, and it on the left hand side block you put in sensor block, and on the right hand side you put 2 motor blocks. And motor blocks make the motors like move. So what would happen is the sensor block, let's say you say, okay, sense 8 inches. Let's say it doesn't do that, then you go on the bottom. If it does do that, then it will do what's on the top. A loop block makes it stop when a sensor senses something, or it just keeps on making it go forever and repeat until you turn it off. And the robot will start when the color sensor gets activated. Your hand should be at least 3 centimeters away from it, or you can use a yellow suit and you just put it in front, and then it'll activate. Now let's say it gets too close to a firefighter, it would stop like this. It would keep a distance. But let's say if a firefighter from the back bumped this one, then it would go forward for 1 second and then keep on stopping. But if nothing's in its way, then it would just keep on going. And the front one would, like, you guys can take off your equipment. These are kind of like things to keep it from going off, so you can like put something here and then lock it up with this. And we have this shelf for you guys to put your equipment on. Now I'll show you how it works. And that was our demonstration. Thank you for listening and watching our presentation.
Very nice. Outstanding. Good work. Good work.
I have a question.
What?
So I still am not clear. What does this robot do?
You taught us.
But I am confused. So I heard about it blocks and I heard it moves, ultrasonic, this, but
Like,
what
what
is the purpose?
It's
The
to
purpose
help.
is to carry the equipment for the firefighters so they can move fast.
Why is it such a big deal?
Because the
then they can
equipment.
get to the fire faster, and let's say it's spreading really fast, then they can get there before it spreads on like so many acres of land.
And what was the inspiration? Why did you?
You guys helped
What was
us.
the big challenge?
You
Oh,
guys
because
helped us inspire about this robot. We came here, I think, a year ago, and we asked you guys questions and what you guys really needed, and you guys said about heavy equipment, and you gave us the inspiration to make PackBot.
Very nice. And so it carries the equipment.
Yeah.
And so what is the purpose of all these sensors and why?
It's
like,
so safety reasons.
Yeah.
So
Like,
that
So
it
what's
won't-
the safety thing?
Like, so it won't bump into the firefighters.
Because if it's running, and then, so if you're wearing yellow, my hand's kind of yellow, and then, so it won't bump into you, because if it bumps, well, yeah. Yeah, so because if it bumps into, if it bumps into you, like, you might trip, and then the fire might spread faster, so, like, it'll keep it away, the ultrasonic sensor.
And that's gonna carry our gear.
we'll show you how it carries the gear.
Oh, so it carries the
Can
gear and follows
Can I?
them,
Can I?
and it stops and it knows when to stop.
Just put it.
So
right
what's
there.
I know
the
what to
purpose
do.
of that thing on the back?
Which one?
This little thing on the back.
It helps it, like, let's say somebody, a firefighter from the back hits it,
Why
then
would
it
they
would,
hit it from the back?
Because they're
they're
walking.
walking, and if it goes faster than them,
But a firefighter can see not to bump into it.
yeah, but let's say something else, like, they don't, what if they don't see it? It's for safety reasons.
Or what if another robot is following, carrying more equipment, right?
Oh yeah, you told us the idea of duplication.
Some other vehicle maybe.
Yeah.
A big fire truck.
See, a human being knows how to avoid an accident.
Usually, if it's like a fire like that and they can't bring a fire truck, they come from an airplane and just go off. And
Right.
yeah, so they're not. It's not gonna have another probably vehicle behind it unless they make another robot.
Okay.
Skydiving.
And also this is a prototype, right? I mean, the actual thing will be much larger, so it can carry the equipment.
Okay.
So Nisha, now put this thing on. So we're gonna show you. See, this locks it up
So it doesn't fall.
Oh.
right there, and then
I didn't know that was the purpose.
really,
No, I didn't.
really,
Yeah,
for real.
for real.
So we'll show you.
Can I do it?
Here, you can click. Just keep
so
on
it doesn't
clicking
roll
this.
over when it's moving.
Click, 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 click,
Yeah.
click.
Oh, I see.
My hand. Yeah, my hand.
It even says hello.
Yeah.
Yeah.
So that you know it got activated.
Hello.
So
Hi. Oh my.
it only goes forward or does it go backwards as well?
No,
What?
it doesn't go backwards.
Okay.
We could make it. Okay, you can have it.
No, I know. No, I know.
Or you can just, the firefighter can just turn around, right? Walk a little bit and.
McQueen, line one.
No. It won't do like that. We could make it because we didn't. At first, we made this because our robot. We didn't have this we didn't have the ultrasonic thing yet. So we have this. Now we could kind of change this and make it do make it. If it hits the thing in the front, it'll move backwards and then
Maybe turn around.
yeah.
Is this Lego parts?
Yeah, Lego Technique parts.
Not Lego Technique, Lego.
The
Monster.
motor and all the sensors, do you get that all Lego or is that, where did you get the sensors?
Oh, from a Lego kit.
Oh, really?
Yeah.
The Legos that my son played with were just little blocks. That's pretty cool. They didn't have any motors or anything
And we
like
also
that.
had these 3 motors. We used the 3-motor chassis, but this motor was kind of useless, so we thought we could add more power if it's going up hills. So we added 2 wheels here.
Well, smart. That's pretty smart. Keeps it stable too. Yeah.
And the back
And we
wheel.
and then like when we were almost done with it, I was changing the program. What I did was I put all of them on 100. I put some of them on 100 and some of them on 75.
What is this 175?
Like, it's how much power you want it to, like, the power of how fast the motor goes.
So whether it's 75 revolutions a minute or 100
It can go
revolutions?
from, it can go from 1 to 100. And it can go to 0 if you don't want it to do anything.
What is the power source? Is it batteries or
No,
you?
it's this. Yeah, it's
Six double A's a day.
Oh,
6 double A's, okay,
okay.
so that's the power pack, the power supply.
Yeah, it's like the brain, and it tells all of the whole robot what to do.
So how does this brain thing work? How does it compare?
Like,
You
so
have to,
you put the plug in through here where it says USB, and you put it into your computer. Then you click the download button on when you're done with your program. It'll send it, and it'll make this beep sound, and it'll say on your computer complete. Then you take it out, and then you start it like this, and
So
go
how-
to your files. Then click software files, and then you go to these. These are all the files we made.
Oh, so you have an LED, is it
Yeah.
Oh, there's
LCD
a
screen?
there.
Okay, so it shows what you're programming in? Did you name the different programs that it can run? Okay, excellent.
Our program's named Test.
Yeah,
okay.
our newest one.
So you can download the programming that you've written,
Yeah.
and then you can run your robot to verify that the programming does what you want it to do?
Yeah.
Okay, very good.
Any questions?
That's amazing. You guys did a good presentation. and
Yeah,
You answered a lot of questions we had during your presentation and the explanation. of things.
outstanding.
That's
Very,
impressive.
very
And also-
ambitious.
This person was not a part of my team, but he wanted to help, so I let him. What we did together is this wasn't that stable. Like, you could easily just break it. So we made it more stable by adding more pegs. And pegs are like these things, these black things right here that connect the what do you call it?
Connect
Lego
the
pieces
segment.
together.
Those
Axles or something.
So basically you put almost a skeleton, you put a stronger skeleton or through them, the spines through there.
And you can add more of those segments to this area as well to create a bigger platform?
But I wouldn't do that because then it would be hard to see the screen.
Oh, that's right.
That's why we
Okay.
didn't. We just covered this part so that you can go like this.
Okay.
Because if we covered it, you would be like. But if we covered it, then you just have to keep on clicking this like this
Right.
and see it all.
So you could
Then
add
it
more
would-
shelves to it though.
Yeah, we can like make it.
Make it
longer
double
here,
decker.
but- Oh, double. What's a double legger?
Double decker, like you know,
yeah.
another shelf on top of
Yeah,
this.
we can use this piece instead of to make it hook. We can put a double decker, but I don't know. Oh yeah, we could.
You could, but
Except
from a
we only
practical
have, like-
standpoint,
But
Except we
how
have,
do we
from a
put it
design
up?
standpoint.
How do we make it
so
go
your
up?
programming is part of this?
Yeah.
Are you design and programming, or are you just programming?
No, yeah, I basically did most of the programming and typing,
Okay.
but my sister did the design and he did like
The
the writing.
building.
Yeah,
So
building,
in
and
the
he
future,
did
when
the
you
writing.
develop your product, you talk to your end user of the product, who's gonna use that, and that end user then collaborates with design to give them feedback on the design that works best for the end user. You as programming can make it do whatever you want it to do, correct?
Yeah,
With your
but,
programming.
yeah, but so, I don't know exactly all of the blocks.
Right, but so your sister's design, so my question is, or my suggestion, if this is going to be used to carry equipment for firefighters, one big thing, and you're talking about firefighting in the wildland, on the grasslands and the forests and things like that, correct?
Yeah.
What kind of terrain do you think this robot's going to encounter?
Grass, hills.
Hills,
Yeah.
what we would call, big term, big word, but you guys are very intelligent, it's called variegated terrain. So it's undulating, rocks, hills, potential for a very unstable platform. So it's moving like this. So what you have to be very careful of with your robot is making sure that the robot, once it's loaded, that the robot's center of gravity is relatively low to the ground. If you put a double decker on there and load your robot with more equipment, you tend to make it top heavy. So on variegated terrain, a top heavy thing could potentially topple over and become useless. But if you lower the center of gravity of the platform, and then your weight is lower to the ground, your platform is much more stable. Think of a skyscraper,
Like our feet?
like we are. Okay,
Our feet
so,
is closer
yeah,
to
if
the
I,
ground.
come here for a second.
It's on the ground.
So, stand here, face your partners.
Hi.
I push you. Now come here. Spread your legs apart, shoulder width, get down lower.
Lower.
Now I push you. See how much
See?
harder it is to, now your center of gravity is lower. Does that make sense?
Firefighter asked me and they pushed him.
Yes. But I'm trying to demonstrate center of gravity. So a lower center of gravity creates a more stable
Lower to
base.
the ground.
Lower to the ground.
Oh, so like your feet, our
Right,
feet
so
is
your
actually
platform, your very great design, a prototype, as Dad said, it's a prototype. Great idea. But if it's gonna carry equipment for us in the wildland, because there's hills and things like that, you want a lower center of gravity, you want your weight to be lower. So perhaps you could invert, put your programming and your power supply up a little higher and lower your carrying platform, so it's lower to the bottom of your robot. That's just an idea. You guys are design and you guys are the big thinkers, but I'm just telling you, I'm the guy that may use it someday. And potentially I could see that being used.
So that's the importance of doing your field research and talking to the people who are actually going to use it.
Getting the requirements.
So you get better ideas as to what kind of design and how to better your design in what you're making. It's got very good potential. It's talking to the person that's going to use it so that you end up with a very good design that's going to be beneficial to the person using it.
I also made another robot. I went to this robotic class, and they have this robot, and I think it's a pretty good design. It's very strong. So you know what I use it for? I sometimes use it for sending my sister things, like some Legos or something. I just put it down, turn it on, and I send it to her, and then she sends it back.
So it's a messenger robot.
Yeah.
You've seen the, what is it, the little robotic vacuum cleaners that they sell?
Oh yeah, my friend has it.
Yeah, it's Simba or something like that.
iRobot.
Zumba robot, there's Zumba or something like that, it goes around and it picks up all the,
Wait,
very
that's
similar,
Zumba?
probably very similar design.
Oh, that's Zoom. Because Zoom is an electrical dog.
Oh, okay. Well, very good, guys. Thank
Very
you for
good.
sharing this with
Yeah,
us.
outstanding work.
Bugs.
Huh?
There's some
Thank you.
electrical bugs.
Yeah.